Hi everyone. I hope everyone is doing good. So today we're gonna do our group presentation and video demonstration about our project. The title of our project is Zone Notification Device for Motorists using IoT technology. As we are a group of 6 members, Ahmed, Saikhar, Kushal, Sisir, myself and Saroj. So I'd like to begin with our project outline. So we're gonna discuss briefly about project details, objectives of the project, project design and implementation, video demonstration, objectives that we achieve on this project, and some limitation and future work as well. Well, talking about our client and stakeholders details, our client is Mohammed Al Khalili. The company name is BRR Technology, and our supervisor is Dr. Sanjeev Shrestha. Well, talking about project details, we have to design and develop an IoT notification system, especially for vehicles while they enter and exit the school zones. Develop a system, the implementation of transmitters and receiver. The notification system will allow the drivers to decrease their speed down to 40 km per hour. So as you have some problem domains, as there are several vehicles that passes through the school zones, and especially children they travel to and from the school zones. There are some drivers who are unaware of or they normally don't pay any attention to the road rules. So likewise, the school zones that may be confusing in regards to where they begin and end. And lastly, there is safety that needs to be improved for the drivers and pedestrians. Talking about our project objectives, so we have to design and develop a low-cost solution. So in this project, we're gonna develop a transmitter which will be installed within the school zone signs, and later it transmits the signals to the receiver part. So similarly, we have to develop a receiver which will be installed within the vehicles. So later it receives the signals coming from the transmitters. So on the receiver section, we have to develop in such a way that it will be able to notify the driver of the school zones. And lastly, so we have to ensure the vehicles within the school zones which are maintained at 40 kilometer per hour.
Hi everyone. Today I'm going to talk about the resources that we have used in our project. For the hardware section, we have used the Arduino UNO and the Waymo T1R2 microcontroller and two IR sensor for the transmitting and the receiving sections, the buzzer alarm, the display board, speed detection sensor, stepper motor, as well as for the software part, we have used the Arduino IDE and Arduino IoT Cloud. Now I'm going to talk about the high-level design for the receiving section. Mainly, this section is located in the vehicle. Here, we have used the different components like IR receiver. This received the message from the transmitting section. And here we have used the buzzer alarm to alert the driver and the stepper motors to control the speed of the vehicles and the display board to display the message to the driver. And all these components is connected with the Arduino UNO microcontroller, and the external power supply of the 5 volt is given. And for the transmitting section, we have the two parts. One will be placed in the starting of the school zone, whereas another part will be placed in the ending of the school zone. For this starting zone, we have used different components like the speed detection sensor to detect the speed of the vehicle, and then IR transmitter to transmit the signal to the receiving part, and then these all components were connected with the Waymo's D1R2 microcontroller, and the external power supply of 5 volt is given here. And for the ending zone, we have used one microcontroller of Arduino UNO, and we have connected IR transmitter here, and this will transmit the signal to the driver and just let driver know that the school zone has ended.
Good afternoon, everyone. Here is the flowchart of our project design. It represents the overall process of our project design implementation. Firstly, when vehicle enters the school zone, the transmitter at the start of the school zone sign will send signal to the receiver. The receiving section is within the vehicle. It will receive that signal, and the Arduino will activate the school zone notification process. For that, the buzzer is rang and the message is displayed on the LCD display. At the same time, the Arduino will activate the stepper motor to reduce the vehicle's speed. And when the vehicle moves towards the end of the school zone, the transmitter at the end of the school zone will send signal to the receiver. And again, the Arduino will activate the notification process. That is, the buzzer is rang and message is displayed on the LCD, and when the vehicle moves past the school zone, the receiving section will turn off. So here is the project design diagram of our project. As you can see, there are two transmitting sections. One is situated at the start of the school zone sign, and the next one is situated at the end of the school zone sign. The receiving section is located within the vehicle. The first transmitter will send the signal so that driver will know that he has entered the school zone, whereas the next transmitter that is at the end of the school zone will send signal so that driver know that he is about to leave the school zone. So here are some of the expected outcomes of our project. First of all, the transmitting section will transmit signal to the receiver, and the transmitting section will detect the speed of the vehicle, and that speed is recorded and stored in cloud platform. And also, when receiving section will receive the signal, it will sound the buzzer and message is displayed on the LCD display. And the last is receiving section will activate the stepper motor to control the speed of the vehicle.
So this is our video demonstration.
Hello everyone, this is our video presentation for our project, Schools and Notification Device for Motorists Using IoT Technology. The idea behind this project is that there will be three sections in the design, which includes two transmitter sections and one receiver section. The first transmitter section will be installed at the beginning of the school zone, which will transmit an IR signal to oncoming vehicles, targeting the IR receiver within them. The receiver section within the vehicle will receive the IR signal and will then notify the driver that the vehicle has entered the school zone. As the vehicle then leaves the school zone, the second IR transmitter section installed at the end of the school zone will transmit another signal at the receiver, which the receiver section will notify the driver that the vehicle has exited the school zone. Now let us look at the hardware implemented. Here is the start of the school zone transmitter section. This consists of the WeMOS microcontroller, LCD display, two vehicle speed detection sensors, and an IR transmitter. This is the section to be installed at the start of the school zone within the sign. This is the receiver section, which will be installed within the vehicle. The hardware used here are the Arduino Uno microcontroller, LCD display, IR receiver, buzzer, and a stepper motor. This section will notify drivers of school zones as they enter the zones. The last section is the end of the school zone transmitter section. It consists of an Arduino Uno microcontroller and an IR transmitter. This section will be installed at the end of the school zone sign to notify drivers that they have exited the school zone. Here is the implementation design of the project. The start of the school zone transmitter will transmit IR signals to oncoming vehicles during school zone hours, and it will record the speed of the vehicles as they pass, and will then create a speed log which is sent to the IoT cloud. The vehicle which has the receiver section will then receive the signals from the IR transmitter and activate the school zone notification process, where the buzzer is rung and the message "School Zone 40 km/h" will be displayed on the LCD. Then the stepper motor is activated to slow the vehicle. As the vehicle then exits the school zone, the end of the school zone transmitter section will transmit an IR signal to the receiver, where the receiver section will then display the message "Exiting school zone" on the LCD display while the buzzer is rung. Then after a short period of time, the receiver section will shut off and await for any further IR signals. Here is a demonstration of how the receiver section interacts with the start of the school zone transmitter section. The receiver section is on the left and the transmitter section is on the right. Here is the demonstration of the speed detectors and the IoT cloud. The speed recorded here was 31.36 km/h. And if we head over to the IoT cloud, we will then see the speed log update. Here the speed log is showing 31.359 kilometers per hour. We can also update the line graph on the cloud to show the latest speed log along with the previous speed logs recorded. Here is a demonstration of how the end of the school zone transmitter section will interact with the receiver section. So as we can see here, the LCD display of the receiver section is still displaying the previous message, but when it receives the signal from the transmitter, it will display the other message. Then now the receiver will shut itself off after that. And finally, this was the demonstration of our school zone notification device for motorists using IoT technology. We hope that you have enjoyed this, and now we will continue on with the presentation. Thank you.
So here we have some of the outcomes which I achieved during this project. As we have three sections, two in the transmitter section, whereas one in the receiver section. So while doing our project, we were able to send signals to the receiver in the receiving section. Also, the speed sensors between the school zones were able to detect the speed of the object passing through it. And whereas in the receiving section, we were able to receive the signals which is transmitted through the transmitter. The buzzer which is placed in order to alert the vehicle seems to be working. The LCD display the message, and also the stepper motor was activated.
So for the limitations of our project, this includes first, the infrared signals can only travel for a limited range before the receiver is then unable to receive those signals. Second, the signals can be blocked by obstacles either in front of the transmitter or the receiver, which will not allow for the signal transmissions to be made successfully. Third, the speed reading by the speed detector sensors are not 100% accurate, which can cause false readings to be sent to the cloud. And the challenges we have faced in this project is one, we had a limited time frame, which we also had to work around the pandemic as well. And second, the coding requires a person to be knowledgeable in code writing, to be able to write the different codes for the different components that were used. And for the future work of this project, we hope to, one, improve the coding of the system, to have the system run better as a whole with little to no errors. Two, improve the speed detectors to display more accurate readings. Three, design and create case housings for the different sections to make them more weatherproof and also compatible to be installed within the school zone signs. Four, improve the transmissions of the signals using different components such as radio frequency transmitters and receivers instead of infrared transmitters and receivers. Five, add a GPS module to track the location of the vehicle to determine whether it is within a school zone or not. And six, add a real-time clock module to allow for the setting up of the school zone hours within the receiver section of the project so that the section will activate the system within those hours. And that is it for our presentation. We hope you've enjoyed it, and